So hello everyone. Today I am available with the one shot for vector theory where we will go through all the basic concept and along with that every questions in that. Okay? So let's continue, okay? So you can ask me doubt on my you can comment below. I can see your doubts and based on that I can reply you, okay? So let's start. So we have vectors and scalars. So we have vectors and scalars. Yes. So we have two different types of quantity. One is vector and one is scalar. So let's continue. Okay. So for one vector quantity. So we have one vector quantity. Let's write it somewhere neat and clean. Let's write it somewhere neat and clean. Can we have neat and clean? So okay, let's continue. Vector. So a vector is a quantity. I will have to choose some ball pen. Let's see. Okay, I have chosen watercolor. It was ballpoint. Okay, a quantity. Yes, this is correct. That has magnitude and direction. This is a vector quantity. So, for example, if I am pointing from A to B, then the direction of this vector is on this side. Yes, from A to B, and it will have some magnitude like we denote magnitude as AB this way. So this is the magnitude. And second is scalar quantity. Scalar quantity has only magnitude. Only magnitude. So this is scalar quantity. Now you got vector and scalar. So we come to notation. So notation is what? Like if we have a point from A to B, then we call it as starting point and B as terminal point. So A as starting point, B as terminal point. And what happens if it is going from A to B? Then how will we write? We'll write AB A to B. So this is the way we do denotes it. So denotes in A to B. In this form we denote it, okay? And magnitude is denoted in A to B with some mod type of structure. So you can see that it's a mod type of structure, isn't it? So this is all. Then next is types of vectors. So see, this content is designed by giving lots of time to it and it is well defined, okay? So now if we go to kinds of vectors, so first we have nothing other than zero vector. Zero vectors. So now what? Zero vector. So we can call it as a point vector as well. Point vector. Meaning what? Starting point and terminal point are same. This is just some type of definition, but we will define it as magnitude of vector equal to 0. Magnitude of vector equal to 0. Now if we are trying to take some example, let's take example. So which type of vector will fall in this? So let's take an example. If we take r vector is equal to xi cap, yj cap, zk cap. So now we will be calculating the magnitude of r vector. So let's calculate. So this is what? Root under x square plus y square plus z square. And we are told that it should be equal to 0. If it is equal to 0, you should be noting that all of them are square. That means individually everyone will have to be 0. Got it? So this is all. So we got everyone need to be 0. That's all we got it. Hence, now onwards, when we are asked what is 0 vector, it is 0 I cap plus 0 j cap plus 0 k cap. This is R vector from now onwards. So this is all. So we should be keeping this very colorful, isn't it? Second, unit vector. So one thing, if we will focus in this, what we can say is that we are defining vectors through their magnitude or direction only. So unit vector meaning magnitude equal to 1, equal to 1. Okay. Now, which type of vector will come? So if we are given with a question, if we are given with the question, like if given r vector is I cap plus j cap plus k cap, find the unit vector. So somewhere unit vector is denoted as this way, which is equal to vector upon magnitude of vector. So what will happen here? We have I cap, j cap, k cap upon magnitude of vector is what? 1 square. The magnitude of this one is what? 1 square. And since they all are perpendicular to each other, so we are writing individually 1 square, 1 square. So if we see, can we say it I cap root 3 plus j cap root 3 plus k cap root 3. So this is the unit vector. Okay. So now we'll be going to the third type of vector. So what is third type of vector? Let's have it. We call it equal vector. So equal vector. So this is equal vector. Okay. That's it. In equal vector, what will happen? See, the vectors are including only two things, either direction or magnitude. So one, if A vectors and V vectors are given, and we are told that tell us about equal vector or not. So first thing is that magnitude of A vector should be equal to magnitude of B vector, and second, direction sense of A vector and B vector are same. Got it? So let's take an example. So before taking an example, yes, we have to take an example. So we will be taking examples. So examples are what? Examples. Okay, let's have example. Hello? Yes, sir, fine. Yes, sir. So, okay. At how much far, sir? Outer ring road. So how much far from Jubilee is? No, sir. I can see it, no problem. But how much far is nearby? Okay. how the students are from there? Like what happened in this building, sir? So in this building, what was the issue? Like students were very brilliant. Yes. Tomorrow in the morning 8 to around 2 o'clock. In between, so at 8 a.m. I can come. 8 a.m. morning. So 10 a.m. sir, before two. Okay, sir. Okay, sir. Thank you. So sorry in between. So direction of trains is A vector and B vector. So let's take an example. So if we take R vector or maybe A vector. So this A vector is what? If we take one example like I cap, J cap, K cap, okay? We got A vector equal to I cap, J cap, K cap. Now what will happen is that we will have second vector B vector. If we keep the sense same, so sense same meaning I cap, J cap, K cap, and if we multiply it with 3 and divide it by 1 by 3, so you see that the sense is same I cap, J cap, K cap, and the modulus 3 will cancel. So overall we can say that it is the same vector. Okay, so we got this equal vector. Now it's time for some more basic vectors I will try to cover here. It is co-initial vector. So we'll have few terms coming like this: co-initial vector. So co-initial vector meaning like this is the vector and this is the vector. They have same initial point. We can write it as same initial point. So this is we have the same initial point, that is co-initial vector. Fifth one, free vectors. So what do you mean by co-initial vectors? If we say O and this is A and B, so we can say that OA vector and OB vector are co-initial vector. I mean that OO are same, isn't it? So now fifth is free vector. So free vector meaning if we shift vector parallelly, there should not be any effect on the vector. So if this is a vector, we are shifting it parallelly. Then if this is A vector, this is B vector. So we can say that on shifting or transforming there is no change in vector. So my question is, what do you mean by no change in the vector? So it is what? No change in a vector, meaning no change in magnitude and direction. So no change in magnitude and direction. Students should not be worrying that I will be providing this all PPT to you all. Okay, so don't worry. So what happens if you have a point object, and if you are applying force, and if you shift it parallelly, you are again applying force. Okay, then the force is going to be the same. So example is force. It will come in physics. Okay, force applied on, this is example. Okay, force applied on a point body. So if you are applying force on a point body, it is okay. And when we go to any solid body, the force at this point will be different, the force at this point will be different. So this is not, this will be localized vectors. It is called localized vector, because if we applying on transformation, on transformation effect changes. So I will mark it in a good way. Okay, I will mark it in a good way. This is localized vector. This is also one of the definition. Okay, this is sixth type of vector. Now we are done with this. So we have few good things now. Coplanar vector. So coplanar vectors, or we call it collinear vector. It's better to write in different color. Collinear vector. Okay. Coplanar or collinear vector. So what will happen? If this is a vector, we call it A, and if this is a vector, we call it B, and if this is a vector, we call it C. If if A vector, B vector, and C vector all parallel, then they are collinear vector. Now, sir, we studied in class 10 that collinear vectors are a line passing through 3 points. They are called collinear. So in this we are telling the parallel lines are collinear. So what will happen? I am taking one example. If there is a line, for example, we keep it a vector as I cap, j cap, k cap. We keep it as a vector. Now what will happen if there will be a b vector on this, and that will be like 1 by 2 I cap, j cap, k cap. So there is a vector which is I cap plus j cap plus k cap. Okay, parallel vector. So what happened when we shift this vector here? This is parallel. Can we say this vector is some multiple of a vector? And if it is some multiple of a vector, this will, on shifting it here, it will lie on this. Similarly, if it is a negative vector, for example, minus 1 by 2 I cap, j cap, k cap. So this is also a vector which is lying in negative direction. So which will be called as C vector. Hence, in vector, if you move it parallelly, they could be shifted, isn't it? It is called a free vector. So this free vector will somewhere lie on the same vector if they have same direction, same parallel slope. So hence they are collinear. And know that these two are with the same sense. If it is with the same sense, it is like vector, and with the different sense, they are opposite sense, a like vector. So I think every one of you are getting. Yes. So we are done with this. Okay, now we are moving ahead. So multiplication of a scalar vector. Okay, so multiplication of a scalar vector. Okay, so after this we'll start solving few questions. Okay, multiplication of vectors by a scalar. So first it will be having something m a vector. Okay, so m a vector could be written as, so m is multiplied with a, so m a vector, this is written as m a vector. That's all. Second, we have m n a vector, which is simply m a vector n, or we can say m n a vector. Third, if we have m plus n into a vector, we can simply write it as m a vector plus n a vector. Okay, now what? Fourth one, if we have m a vector plus b vector, we can simply write it as m a vector plus m b vector. So we got that. So these are the few basic things. Example for example, if we are telling we want some example. So if we say that it is 4 I cap plus j cap, we can simply write it as 4 I cap plus 4 j cap. This is normally. Now we'll come to few questions. This is the time for question. Find the unit vector. So find the unit vector of this thing. So the vector is, we will take first vector as like this: I cap minus 2j cap plus 3k cap, and we have to write unit vector. So unit vector is what? This is the symbol for unit vector, which is a vector upon magnitude of a vector. So we have simply I cap minus 2j cap plus 3k cap upon root under 1 square minus 2 whole square, which is plus 2 whole square plus 3 whole square. If we calculate it, it is 1 plus 4 5, 5 plus no 9 14. So we can see that I upon root 14 2 j cap upon root 14 3 k cap upon root 14. So this is the unit vector. I think you got it. So this is the unit vector. Now we are again on the next question. A equal to x plus 1 I cap minus 2x plus y j cap. This is the question. We are given that find x vector. X is not a vector, it's a some quantity, okay? Constant quantity, scalar quantity. So find x and y for which a vector, b vector are parallel. So we know that if they are parallel, a vector will be some multiple of b vector, and similarly we can say that coefficient of I cap will be in some ratio of coefficient of b cap, coefficient of I cap in b vector. So we can simply say that x plus 1 upon 2x minus 1 equal to minus of 2x plus y upon 2 plus 3y is equal to 3 upon 1. How we got this? This one divide by this one divided by this one, this one divided by this one. So we are getting 3:1. So now we'll take this one and cross multiply. So we'll get x plus 1 is equal to 3 times of 2x minus 1. On further solving, x plus 1 equal to 6x minus 3. Further solving, 5x equal to 4, x equal to 4 by 5. So this is what we got. From here we got this thing, isn't it? Now we will come again. So for again what? Again what? We will solve this part, which is minus 2x minus y is equal to 2 3s are 6, 3 3s are 9. We'll have minus 2x minus 6 equal to 10y. We'll go further. So x is 4 by 5. So we'll put 2 into 4 by 5 minus 6 equal to 10y. We'll solve it further. Minus 8 taking LCM minus 30 upon 5 equal to 10y. Solving it further, minus 38 upon 50, we can further write it as minus 19 upon 25 equal to y. So we can see that we got the value of x and y. Got it? Next. Now we are moving to the next question. So next question is, given a regular hexagon A B C D E F with center O, so that OB vector minus OE vector, OD vector minus OE vector. So we have to show all of these things, okay? So for that, what will we start? We will start with a drawing. We'll start with a drawing from corner side, okay? This is a line. We have to draw a regular hexagon. So if you see from here, regular hexagon will be at 60 degree and then 120 degree and then 60, 120, 180, then 240 and then this way. So we can say that this line could be joined to this one to this one, this one to this one, this one to this one, this to this, and hence this to this. So it's a regular hexagon. Okay. So now what? Now we have O A, B, C, D, E, F. This is what we have. So in regular hexagon, if we put this point as A comma 0, and this length we know that it is A only, and this is 60 degree. So can we say that it is A cos 60, which is 1 by 2, comma A sin 60. It is a reflection on this. So in this, what will happen? X will become negative, Y will stay with the same sign, and everything same. Here it is A comma 0. Here it will become minus A comma 0. Here it will become, this is opposite of this one, minus A by 2 minus A root 3 by 2. In this it will become X is positive, Y is negative. So this is the key for solving this question. If we are done with this, I think we won't be facing problem in any of this part. So if we start with part 1, OB vector is what? A by 2 I cap plus A root 3 by 2 j cap. So this point minus 0 comma 0. So we got this thing OB vector. This is OB vector. Yes. OA vector. OA vector is simply AI cap plus 0 j cap. And one thing you should be noting that we are just in two-dimensional figure. So we are going only up to j cap, not k cap. Okay. So this is what? If we go through this, it is simply minus A by 2 I cap plus A root 3 by 2 j cap, and OD vector minus OE vector. So OD vector minus OE vector. So OD vector is OD minus O, which is minus A I cap. Okay. Minus A I cap and minus of OE vector, O to E vector. So it is minus 1 by 2 minus A by 2 I cap minus A root 3 by 2 j cap. So this is simply, if you solve it, this it will become minus A by 2 I cap plus A root 3 by 2 j cap. If you see from the figure, this this and this, they are the same. So we can prove this. Okay. So now we'll move to second part. EA vector is equal to 2 times of OB vector plus OF vector. So I would request everyone who are live, okay? Everyone who are live, go through this question. So my question is, start solving this one. So EA vector, E A vector. So first we'll go to A vector, and then from E to A. We are making a line from E to A. So this is simply A I cap minus A by 2 I cap minus A root 3 by 2 j cap is E a vector. So let's calculate this. It is 3A by 2 I cap plus A root 3 by 2 j cap to OB vector. So O to B is somewhere 2 times of OB vector. We already calculated somewhere here. Yes. So if we multiply 2, so we are directly multiplying 2. Wait for some time. Okay. They should be giving us eraser. They are not giving you. Okay, no problem. Leave it. It should be giving us eraser. Here we are not getting eraser. Yes. Let's continue. Okay. 2 times A by 2 I cap plus A root 3 by 2 j cap is equal to A I cap plus A root 3 j cap, and we have to go by OF vector, isn't it? So OF vector, F point is what? This is the point. So F minus 0 comma 0, which is A by 2 I cap minus A root 3 by 2 j cap. If we add both of them, this and this, we are simply going to get 1 plus 1 by 2, which is 3 by 2 A I cap plus A root 3 by 2 j cap. So if you see that, we are again able to show this and this as equal. Yes. Okay. So similarly, now we will be going to the third part. Third part is AD vector plus EB vector plus AC vector. So what will happen? AD vector. AD vector is normally A minus of A, 2A vector. Yes. So third one, AD vector is 2A I cap. EB vector, E to B. So it is again 2 times of every of these things. So A I cap, A root 3 J cap. E B vector ai cap a root 3 j cap. FC vector. So it is again F to C. It was E to B, F to C. That means minus A plus A root 3. FC vector minus AI cap plus A root 3 J cap is equal to 4AB vector. AB vector is what? A to B minus A by 2 plus A root 3 by 2. AB vector is A by 2 minus A, which is minus A by 2 plus A root 3 by 2 J cap. So what will happen? We have to find 4 times of AB vector, which is minus 2A I cap plus 2A root 3 J cap. We are told that 4AB vector is equal to all this sum. So let's see all this sum. This, this and this. Let's sum it, okay? 2, 1, 3. A cancel. So we are simply getting 2A I cap. So this is 2A root 3 J cap. So simply we can see that AD vector. Okay, we are going from A to D. That means minus 2A. So this is minus 2A. So here we'll get minus. So if we see that this time also we got this and this. To be the same. Hence we are done with this. Now moving to this one. Moving to the next question. A, B, C, D, E, F be a regular hexagon. So we have already done hexagon in the previous question. We'll take help from there. Okay. So we have A, D vector. What is AD? Let's check. Let's check it. A to D is minus 2A. A to D is minus A, which is minus 2A. Minus 2A I cap. We'll check B, C vector. So BC is what? B to C minus A by 2 minus A by 2, which is minus A minus A. That is minus A only, because A root 3 by 2 minus A root 3 by 2 is 0. So minus A. Which is BC vector is minus A I cap. So we are told that AD vector is x time of. So if you see, it is minus AI cap into 2. So AI cap is BC. So 2 BC vector. So can we say that this is X? Got it? Now we are going for CF vector. CF, C to F, it is A by 2 minus of minus A by 2, which is A, and this is minus A root 3 by 2 minus of A root 3, which is, so this is overall A I cap minus A root 3 j cap. CF vector is A I cap minus A root 3 j cap. We have to tell AB vector. So A to B is minus A by 2, A root 3 by 2. AB vector minus A by 2 I cap plus A root 3 by 2 j cap. We are told that AB vector is Y type. So if we write CF vector, and in AB we are taking minus 1 by 2 common. No, here in AB vector we are multiplying minus 2 and dividing minus 2. So on dividing minus 2 we are getting A by 2 I cap plus A root 3 by 2 j cap. So we are simply getting minus 2 time of A B vector. Can we say this is Y? Then we are asked what is X into Y. So 2 into minus 2, which is minus 4. So we got this as a answer. Got it? Moving to next question. We are moving to next question. Yes. So sum of the two unit vectors is a unit vector. So let's take A vector as AI cap plus BJ cap plus CK cap, and second unit vector XI cap YJ cap ZK cap. We know that both are unit vector. So can we say that root under A square plus B square plus C square is 1? Similarly, x square plus y square plus z square is 1. We got this. These are unit vectors. Sum of two unit vector is a unit vector. So sum of two unit vectors. So these are unit vector. We'll sum it. We'll get somewhere A plus x I cap B plus y j cap C plus z k cap. So this is also unit vector. It is told that this will be also coming out to be a unit vector. That means root under a plus x whole square b plus y whole square plus c plus z whole square is equal to 1. Let's square it. It is a square x square 2ax b square y square plus 2by c square z square 2cz is equal to 1. So if you see from here, a square b square c square is 1. From here if you see, similarly x square y square z square, this is also 1. From here if you see, now we are left with 2 times of ax, 2 times of ay by and 2 times of cz equal to 1. Now 1 cancel, we are getting 2ax 2by plus 2cz equal to -1. And now if we try to create the difference of a vector minus b vector, we will be getting what? A minus x I cap b minus y j cap c minus z k cap. Then magnitude of their difference, that is a vector minus b vector. If we go, it is root under a minus x whole square b minus y whole square c minus z whole square. It will come out to be root under a square x square minus 2ax plus b square y square minus 2by plus c square z square minus 2cz. If we go further, a square b square c square is 1, x square y square z square is 1, and 2ax 2by 2 minus of 2ax 2by 2cz is plus 1. So this is plus 1. Can we say it is root 3? That's all. We are done with this question. Now slowly and gradually we will start moving towards some advanced level of question, so which are most probable to come in JEE mains. Okay, so we'll start moving to such type of question. So let's continue with this. So this is a physics type of question. Okay, physics, a basic physics. If we consider this, okay, wait. Hmm. Now eraser is working. Okay. if we consider this as a coordinate axis, okay, and now we place vector somewhere like this. One vector, we place some vector like this, and we are placing one vector like this. They are all are of same magnitude, and one vector like this. The way it is given above, we are doing the same. So what will happen is, now if we consider this is going from 0 to positive direction. So if we shift this, it will be becoming k I cap. And when we will resolve this one, it will come out to be somewhere this way and somewhere this way. So it will come out to be k cos 45 degree k by root 2 I cap plus k by root 2 j cap. Okay, and this vector is k by 2. No, it's simply k, not k by 2. It's simply k j cap. And if we try to solve this one will come out to be in this direction, which is minus k by root 2 I cap, and it will come out to be in upward direction, which is k by root 2 j cap. So my question is that if you find net, so we have one k I cap, from here we have k by root 2 I cap plus k by root 2 j cap. From here we have k j cap. From here we have minus k by root 2 I cap plus k by root 2 j cap. If we try to find the net, so this I cap and this I cap is going to be cancelled. We are left with only k I cap, and in this side we are getting 1, 2 and 1. That means root 2 plus 1 into k j cap. Now we have to find the magnitude of this one. So to find magnitude, we will simply do what? Root under k square plus root 2 plus 1 whole square k square. If we try to solve it further, we'll get k outside. It is root under 1 plus 2 plus 1 plus 2 root 2, which is simply k root under 4 plus 2 root 2. This is our final answer. Resultant magnitude. Okay, we are done with this. Moving to next. Okay. So I have noticed that this part, this region is not visible by you all. Okay. Because okay, this part is not visible by you all because there my picture is coming. Yes. So this question is from JEE Advanced previous year question. I will tag it as JEE Advanced, and which is most probable to come in JEE Mains. Okay. So we'll be continuing this. Okay. So we are given Z1 equal to A I cap B J cap, Z2 equal to C I cap D J cap are two vectors in I cap and J cap system, where mod of Z1 equals to mod of Z2 equal to R, and Z1 vector into Z2 vector is 0. Okay. So W1 is AI cap plus CJ cap, W2 is BI cap DZ cap. Okay. So what will happen? First we are given Z1 mod, which is root under A square plus B square, Z2 mod, which is root under C square plus D square. Okay. This is equal to R, this is equal to R. That's great. And Z1 vector dot Z2 vector is equal to 0. So if we see here, it is simply what? A dot C plus B dot D is equal to 0. We can further say that it is A by AC equal to minus BD. Similarly, we can say that A by B is equal to minus D by C. And similarly, if we square both the side, it is A square by B square equal to D square C square. Similarly, add 1 both the side. It is A square B square plus 1 equal to D square C square plus 1. Now what? So now what? This is the question. Now, proceeding further, we have A square, take LCM both the side, A square plus B square upon B square is equal to D square plus C square equal to C square upon C square. We know that A square plus B square is R square and C square D square is R square. So we have R square upon B square equal to R square upon C square. If we cancel R square both the sides, can we say B is equal to plus minus C? So if we can say this thing, B equal to plus minus C and B is equal to plus minus C. So we can say similarly by putting this in this. A is equal to, when B is plus C, A is equal to minus D. So minus plus D. Can we say that? So we can say that, we can say this thing clearly. Similarly, we can say this thing. Then what? So we got this thing. So if we write W1 vector, it is AI cap plus CJ cap, and W2 vector as B is equal to plus minus C and D is equal to plus minus A, minus plus A. Okay. If we see the magnitude of W1 is equal to magnitude of W2. So option D is wrong. So option D is wrong. W1 into W2. W1 vector into W2 vector is what? Plus minus AC and minus plus AC. So what will happen if it is plus, it is minus? That means it is 0. If it is minus, it is 0. That means this is correct. Option C is correct. And when we take mod of W is A square plus C square. Determinant of W is A square plus C square W1. And determinant of like modulus of W2 is again A square plus C square. Or we can say it was what? B square D square. So if you add both of them, square Z1 square and Z2 square, we are going to get A square plus B square plus C square plus D square is equal to 2R square. And if you see, C is equal to like B is equal to C, D is equal to A. So this is 2 times of A square plus C square. A is equal to D, B is equal to C. Okay, this is 2R square. So can we say that A square plus C square is R square? And similarly, can we say that B square plus D square is again R square? That means mod of W2 and W1 are R. So this is the question from IIT previous year. So good question. So this time what happened? This space, this space is somewhere what? Like this is covered by my picture. So this time I did not go this side. Yes. So you could see everything. Okay, no problem. So we are on second lecture. Now we are on second lecture. Okay. So can we have a break? So we are on the second lecture. Otherwise, let's continue. Now we'll move with addition vector, triangle law of addition. So let's continue with the triangular law and everything. Okay. we know from our basic knowledge that we know from our basic knowledge that if this is the vector, this is the vector, we are joining their point, then the resultant vector will come out to be this one. This we know. If you don't know, I am telling you, okay? If this is A vector, this is B vector, then the point joining the two end will be called as A vector plus B vector. Okay? If anyone having doubt, they can put the comment in the comment section, okay? So you can put any comment, okay? That sir, I am facing problem in this part and that part. So I am ready to hear you all, okay? Okay, so continue. Triangular law. This is the triangular law, okay? So if we write it A, we are giving it a nomenclature A, B, C. So AB vector plus BC vector is equal to AC vector. Okay, that's all. So that is the triangle law, okay? Parallelogram law. Parallelogram law. So this is parallelogram law. So in parallelogram law, what will happen? If it is not appearing parallelogram, please consider it as a parallelogram, okay? Parallelogram. It is A, B, C, D. Okay? If this is A vector, this is B vector. Now we are expert that we can shift this parallelly here, isn't it? And we know that using triangular law, this diagonal will come out to be A vector plus B vector. Using triangular law, we got this thing. Got it? Got it? Okay, sir. So it is simply A B vector plus B C vector is equal to A C vector. That's all. Parallelogram law. Okay, so now we got properties of addition. So we got that addition marks. Now we are at properties of addition. Okay. So what are the properties? So simply we have those properties like commutative, associative. Okay. Everyone, I am seeing your message. Okay. If you are messaging and if you have any doubt, I will be ready to clarify those doubt. Okay. So don't worry to ping me. Okay. So it is that A vector plus B vector is equal to B vector plus A vector. So this is what? Commutative. We can say that this is commutative law. Second, A vector plus B vector inside a bracket is added to C vector. We can simply say it as a associative law. A vector, B vector plus C vector. This is associative law. Okay. These all are the basics and that need to be covered, isn't it? A vector plus 0 vector is 0 vector plus A vector. That also we know. Nothing added to nothing will be the same thing. Fourth one, A vector plus minus of A vector is equal to 0 vector. And similarly we can say that minus of A vector plus A vector is a 0 vector. Okay. Fifth one, magnitude of A vector plus B vector. What will happen? A vector and B vector, when they come out to be of same sign, they are equal to magnitude of A vector plus B vector. And when they are of opposite sign, they will be less than A vector, magnitude of A vector plus B vector. So this is a triangular inequality. Similarly, magnitude of A vector minus B vector. This is simply like this, okay? Nothing other than, okay? So they could be of same sign. When they are of same sign, then they are exactly getting subtracted. If they are of same sign, then they are somewhere like this. Mod of the difference of their magnitude, modulus of the difference of their magnitude, so they are equal to that. And when they are of different side, then they will become bigger than this. So this is also triangular inequality. This is bigger than equal to this. So these are the basic concept that we should be knowing, and it should be given while going for one shot. So I gave you all. Okay, now move to next one. Okay, now this is the time for questions. Okay, this is the time for all the questions. The two sides of a triangle are given as AB vector, AC vector. Then find the length of median through A. So let's have a drawing. I'm choosing some differently. Is it visible? It is visible, yes. So AB vector, AC vector. Okay, I draw it. Okay, I will take only yellow. Okay, no other. And it could be joined using this also. If it is AB and this is AC, okay. We don't know the sense of vector right now. Up to now, we don't know the sense. This is A, this is B. AB vector, AC vector. Then find the length of median through A. So find the length of median through A. Okay. So what will happen? We have to find either BC vector or CB vector. So in order to find BC vector, can we say that B to C we have to come? That means we should convert this into AB vector minus of AB. So BC vector is AC vector minus of AB vector. So AC vector is what? 2, comma 2, comma 1 minus AB is what? 2, comma 4, comma 4. Overall, what are we getting? 0 minus 2 minus 3. Okay. Now what? Median, now we got BC vector. So it is somewhere like this, okay? Let's draw it now. Now median is dividing BC vector in the ratio 1 is to 1, or we can say 1 is to 1. So what will happen if we take it BD? If you remember when we were proving that collinear point, we were taking BD vector is 1 by 2 of BC vector. We should be agreeing with that, because 2 time of BC vector is BD vector. 2 time of BD vector is half time of BC. 2 time of BD vector is BC vector. So BD vector will come out to be what? 1 by 2 of this thing, which is 0, minus 2 by 2, minus 3 by 2, which is 0, minus 1, minus 3 by 2. Now we have to find AD vector. So AD vector is what? A to D. That means AB and then AD. AB and BD. So AB vector plus BD vector. So AB vector is what? AB vector is 2, 4, 4, and BD is what? 0, minus 1, minus 3 by 2. If we add it further, 2, 3, 5 by 2. Okay. So we have to find the magnitude of AB vector. This is what we are asked that find the magnitude of the median. So this is root under 2 square, 3 square, 5 by 2. So this side is not visible, isn't it? So I won't be going this side. So 5 square, 2 square. If we solve it, it is 4 plus 9, 25 by 4. This is root 77 by 2. Okay, so this is the length of median. Now we are moving ahead. Okay, now this is what in a triangle ABC. D, E, F are the midpoint of BC, CA, AB respectively. Then prove that AD vector is equal to minus of B vector plus CF vector. So for that, what will we do? What will we do is we will first draw a triangle. So we draw a triangle. Now what to do again? Again, now what to do? So we'll take it A, B, C. We are told that D, E, F. D is here, which is midpoint. E is here, midpoint. F is on AB, okay, midpoint. Then prove that B, AD vector is minus of BC. So we should be simply proving that AD vector plus B vector plus CF vector equal to 0 vector. That means they are coming 0. So this is one trick. One trick what? If it is coming out to be 0, why can't we take this as A vector, this as B vector, the position vector we are taking, okay, this as C vector. So the midpoint will come out to be A vector plus B vector by 2. This is B vector plus C vector by 2. This as A vector plus C vector by 2. We got it. Now we have to simply find AD vector. Find all those vector and substitute, put in this equation normally. So AD vector is what? A to D. A to D is B vector plus C vector by 2 minus A vector. AD vector we got it. Now B E vector. So B to E. We are moving from B to E. So this direction, so first this point and then this point. So it is A vector plus C vector by 2 minus B vector. And then we have to find CF vector. C to F is this vector minus this vector, okay? So simply what will happen? We'll have A vector plus B vector upon 2 minus C vector. If we add all of them, you will find that B is appearing two times, A is appearing two times, C is appearing two times. That means the sum is going to be A plus B plus C, and this side A plus B plus C. So overall, AD vector plus BE vector plus CF vector is equal to 0 vector. So that's all. Move to, okay, now move to next concept. Okay, now we will be moving to next concept. The concept is position vector. So my question is, first of all, we took the question, basic questions of parallelogram, and then now we are moving to position vectors. So position vectors are what? This is origin. Okay, this is origin, and this is a point A. Then from this origin, this point will be having some coordinate axis. For example, this point is A, x coordinate is A, y coordinate is B, z coordinate is C. So this point vector is called as position vector. So the position of this point is A B C. So we can simply say that, okay, wait a second. Hello sir. Yes sir. Okay sir. So sir, I will be having talk with the dean sir. Yes, sir. Okay sir. Thank you sir. So this will be like this. This vector minus this vector. Okay. So what will happen? Position vector is this thing only, like this point with respect to origin. With respect to coordinate axis, what is this point? That is position vector. And my question is that we have few good question on this when it comes for cuboid type of thing. Okay, so you get somewhere good question. So I am taking a coordinate axis. So if this is a coordinate axis, we are drawing now three dimensional. Okay, this is x, this is x, this is y. If you do right hand thumbs, right xy, so this will come out to be z. Got it? So when this is the point, we'll make a drop on this coordinate, and then we'll make a drop joining this one and joining this to this one and from this one. So we are getting somewhere a cuboid type of coordinate system, isn't it? This point is lying on the cuboid, somewhere diagonal of the cuboid. So this point will be called as somewhere, if it is x and z, so y is 0. So this will be called as a comma 0 c. This point will be called as, it's just a x, a comma 0 comma 0. Let's change the color. If this is z, so it will be called as 0 comma 0 comma c, and thus this is corner. So this is how it is represented. Position vector meaning this. And if you have to write OA, if you have to write the position of OA vector, then what we'll do, we'll write position of A vector minus position of O vector. So A is, for example, A, B, C, and 0 is what? 0 comma 0 comma 0. So it is simply AI cap, BJ cap, CK cap. Got it? So this is position vector, okay? So we know the point. The difference of this point and the 0 point is their position vector. That's all. That's the concept. Okay. Now based on that, we are getting few questions. Yes. So we'll be getting have some questions. So sir, what is the application? Let's show me. I'm the newbie going for one shot. Yes. So this is what we have. So in regular pentagon, our 360 degree will be divided into 5 parts. So 360 upon 5 is 72. So what will happen? 72, if we try to draw it from this side 72, this point will come somewhere. So let's change the ink. So regular pentagon. O be the center of the pentagon, okay? So 72 may be like this. Center is this. This is very crucial question. 72. Pentagon, 5 side, okay? And OA is A vector. OB center of regular pentagon. We have to find 5 side, 5 side. Uh, 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 uh. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is regular pentagon. So what will happen? This will become regular pentagon 72. Okay. So let's attempt using considering this. Okay. We know that we don't know how the center will fall in between. Yes. So let's consider this. This is 0. Center is this. OA is A vector. Okay. Only this clue has been given. Now find AB, BC, CD like that. This is A, B, C, D, E. If OA is A vector, okay, the center of regular pentagon ABCD, OA is A vector. So magnitude of OA is mod A, okay. The angle between A and B is 72 degree. and this is 36 degree. Okay, so magnitude A, this will come out to be A cos 36 degree, comma 0. A cos 36 sine 18 is root 3 root 5 minus 1 by 4. Cos 36 is root 1 root 5 plus 1 by 4. Root 5 plus 1 by 4, comma 0. So what will happen? Then B will become what? If B is some B magnitude, let's take it B magnitude, then B cos 36 will have to be this thing. Okay, okay, okay. If we consider this as B vector, okay. So AB vector will come out to be what? AB will come out to be, this should be the initial point, going like this and then like this. Arrow should be like this. So it is AB vector will be this point minus this point. Yes, and what will happen? We take A vector, B vector, C vector, D vector, E vector. Okay, we will take this as E vector. And what will happen? AB, BC, CD, DE, A. Okay, one thing I would like to do is that it is a simple question. Okay, I'm looking for eraser. Okay, if eraser is not coming, no problem. Okay, yes, eraser has come. We don't have to go in that much cos theta sin theta thing. Okay, oh, it is from center. Yes, okay. So this is this thing B vector. Yes. So what will happen? AB vector is B vector minus A vector because it is going from here to here. This arrow and then this arrow. Now BC vector is B to C we are moving, so it will become C vector minus B vector. And CD vector will become D vector minus C vector, and DE vector will become E vector minus D vector, and EA vector will become A vector minus E vector. Now what we have to do is that we have to do 2 times, 3 times, 4 times like that. Yes. So if we add it the way it is given, the way it is asked, it is what? B vector minus A vector plus 2 times of C vector minus B vector plus 3 times of D vector minus C vector plus 4 times of E vector minus D vector plus 5 times of E vector A vector minus E vector. If we solve it, what will happen? Let's calculate. It is 5A vector. From here we are getting 5A vector, and from here we are getting minus A vector. From here we are getting minus 2 plus B, which is minus B vector. From here we are getting minus 3C plus 2C, which is minus C vector. From here we are getting minus 4D plus 3D, which is minus D vector. From here we are getting minus 5E plus 4E, which is minus E vector. If you remember, this is going in circular form. AB vector, BC vector, CD vector, DE vector to EA vector. So A vector plus A vector, B vector, C vector, D vector, they are going to be 0. If it is a cyclic loop, like A vector, B vector, C vector, then A vector plus B vector plus C vector is equal to 0 vector. Similarly, A vector, B vector, C vector, they are cyclic loop. So it is going to be 0. Hence the answer is 5A vector. Okay. Got it? We are moving to next one. Express vector BC vector, CA vector, AB vector express okay, express BC in the form of OA, OB, OC. Okay, okay. So this is the very basic question. So BC, if we go to coordinate axis again, let's have a coordinate axis once more. So what will happen? Let's take this is OA vector. This is OB vector. This is OC vector. Okay. So this is O vector. We take it A vector, B vector, C vector. Now we have to find B to C. We have to find B to C with this direction. BC vector, we have to find C to A. C to A. And we have to find A to B. Okay. So what to do in that case? See, in OB, we have to find B to C. That means B should be the co-initial point. That means in place of OB, we'll write minus OB. If it is minus OB, this direction will get opposite. So it will come out to be somewhere B to O, and then O to C, then it will follow a triangular rule like this. Yes, B to C. So this is minus of OB plus of OC. So this is BC vector. This is BC vector. And now we are going for CA vector. So C to A vector. So origin this, if you are moving C to A, we are given OC vector. So this should be co-initial point. So it will become CO vector. And CO vector is minus of OC vector. Yes. And OA vector we know. So it is simply OA vector minus OC vector. Now we have AB vector. So now I think you became expert in this. So AB vector is what? So A should be the initial point, but here A is the ending point. So we'll write minus of OA vector plus of OB vector. And if you want to simplify, you can see that this is OB and this is AO. So O and O will merge and it will become AB, isn't it? So now AO plus OB is AB. So simply it is minus of OA. So this is how we have to solve. Got it? We are moving ahead. In this question, A vector, B vector are position vector of the point 1 comma minus 1, minus 2 comma m. Find the value of m for which A vector and B vector are collinear. Okay. So which type of question has they asked? Let's work on this. So we can consider that OA and OB are lying on the same direction on the same line, isn't it? By the collinear definition, we know this thing. So now what? So now what? If we consider this is 0, this is A, and this is B, can we say that OA vector is lambda time OB vector? We can definitely say that they are in the same flow, so their coefficient are 0. So in OA, it is told it is A vector and it is told it is lambda time B vector. And similarly, A vector is what? A vector minus 0 vector, and this is lambda time B vector minus 0 vector. B position vector minus 0 position vector. So A vector is what? 1 comma minus 1 and 0 vector is 0 comma 0. And here we have lambda time B vector is minus 2 comma m minus of 0 comma 0. It is overall going to be 1 comma minus 1 equal to lambda time minus 2 comma m. So what will happen? They are collinear. So we can say that 1 is equal to minus 2 lambda and minus 1 equal to m lambda. So we can say lambda equal to minus 1 by 2, and when lambda is minus 1 by 2 we can say m is 2. Are you clear or not? So this is the way we have to solve the question. Okay, that's all. Move ahead. We are on third lecture, that is direction cosine. So we can have a few seconds of break. If you are looking for few seconds of break, we can have those. So we can have a break and we can continue, okay? We are moving to direction cosines and direction ratio. So these are the basic concepts that need to be covered, isn't it? Direction cosine, direction. Normally in some of them we teach this when we study planes, but in some of the places these are taught in initial point only. So how a direction cosine is defined? Okay, so how will a direction cosine will be studied? Yes, so we will have a coordinate system. Okay, and in that we will have, okay, this is a z axis, okay, xy. This is a three dimensional, okay, three dimensional x y z. In three dimensional we have a line in a three dimensional, okay. What will happen, we'll consider that this is I cap, this is j cap, this is k cap, okay. So now what will happen, I'm saying you, wait a second. So if this is uh, 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 if this is what we take it as a unit vector, like li cap, mj cap, and k cap, okay. So if we take dot product of this line with I cap, this is I cap, J cap, K cap. If we are trying to measure what is the angle subtended by this, if we take it alpha, with this as beta, with this as gamma, okay. So what will happen if you see Li cap plus mj cap plus nk cap into dot I cap is what? L, which is equal to root under L square plus M square plus N square modulus of I cap plus cos alpha. Okay, so we simply got L equal to cos alpha. Similarly, okay, this is one. Similarly, we have Li cap mj cap nk cap dot with j cap. We can say this is m, which is equal to root under L square m square n square dot j cap cos beta. Can we say that thing? We got m equal to cos beta. Now third thing, similarly we have Li cap mj cap nk cap dot k cap equal to, it will come out to be n, which is root under L square m square n square modulus of k cap plus cos gamma. You can get n is equal to cos gamma. And initially when we took Li cap, M, J cap, N, K cap, it was a unit vector of the given line, isn't it? So what will happen? We got this thing. We got this thing. We got this thing. Yes. Now what will happen if we square and add all of them? Can we say L square plus M square plus N square is equals to cos square alpha cos square beta cos plus cos square gamma, and we know that L square plus M square N square, the modulus is 1 because we took as a unit vector, so this is 1. So here cos alpha, cos beta, cos gamma, they are direction cosines. Okay, these are their direction cosines, and L M N are direction ratio. So L is the value of cos alpha, so the value, okay, so this is what it is. So what is direction cosine? So this is direction cosine. So what is direction cosine here? I will say this is direction cosines. These are direction cosines, okay, whose sum is equal to 1. And you should be knowing that the value L is the value of cos alpha. So L is what? Direction ratio. Okay. So we'll do it later. But I think you got the concept, isn't it? Now we are moving to some good question. The use cases for this thing, isn't it? If a line makes an angle alpha beta gamma with the coordinate axis, so that is my what, this line is making alpha beta gamma with the coordinate axis, then find the value of this thing, summation of cos 3 alpha upon cos alpha. Okay, so what will happen, we know that cos square alpha plus cos square beta plus cos square gamma is 1. This is what we know already. So what I will do is that I will find summation of cos 3 alpha upon cos alpha. So can we say this summation is somewhere 4 cos cube alpha minus 3 cos alpha upon cos alpha, which is what, summation of 4 cos square alpha minus 3, and we know that it is alpha beta gamma, this is alpha beta gamma. Can we write this as 4 cos square alpha cos square beta plus cos square gamma minus 3 for cos square alpha 3 minus 3 for cos square beta minus 3 for cos square gamma. Can we say this is 4 minus 9, which is minus 5? So I think you got the process of solving this question, how this type of question should be solved, isn't it? Find the direction cosines of a line in xy plane making an angle 30 degree with x-axis. So this is all about geometry, isn't it? So this is x, this is y, this is z. Okay, so now what, now what, in xy plane, so this is x, this is y, and this is z. Okay, xyz plane, in xy plane direction a line is lying in xy plane. Okay, so this is xy plane, a line is lying on this. Okay, let's see, this is the line, it makes 30 degree with x-axis. Okay, so this line is making 30 degree with this, it is making 30 degree with x, and this is y, and this is z. And direction cosine of a line. Okay, so if line is lying already in this, so can we say with y it is making 60 degree, and we know that cos square alpha plus cos square beta plus cos square gamma is equal to 1. We know that alpha is 30 degree, beta is pi by 3. What is gamma? That we have to calculate. So this is our aim, isn't it? What will happen? We'll write cos square pi by 6 plus cos square pi by 3 plus cos square gamma equal to 1. So if we say, I think these all are going to be 1. So cos square gamma is 1 minus 1, which is 0. So cos gamma is 0. So gamma could be pi by 2 or 3 pi by 2. No, cos is 0. Okay, so 3 pi by 2 is also 0. Okay, so these are the possible value. If it is acute angle, then cos alpha gamma is pi by 2. Okay, so we got direction cosines. So direction cosines are what? Direction cosines cos pi by 6 is root 3 by 2. Cos beta means pi by 3 is 1 by 2. Cos gamma is 0. These are the direction cosines. Okay, okay, now let's proceed next question. A line makes an angle 60 degree with x-axis, y-axis each, then angle which it makes with z-axis. So now we won't be going with coordinate drawing. We already know that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So cos alpha, we'll take alpha equal to beta equal to pi by 3. So let's put it, cos square pi by 3 plus cos square pi by 3 plus cos square gamma equal to 1. So we'll get it as 1 by 4. 1 by 4 cos square gamma is 1. So we'll get somewhere cos square gamma is equal to 1 minus 1 by 2, which is equals to 1 by 2. So cos gamma is equal to plus minus 1 by root 2. So gamma could come out to be pi by 4 or pi minus pi by 4, which is 3 pi by. Okay, so angle it makes with, so what could happen is that I am showing you the visualization. Okay, so I am showing you the visualization is that this line could be somewhere, if this is x, this is y, this is z, this line could be making, this line is like this. So with the positive x-axis it is making some angle, it is making some angle. Otherwise this line could be of this type and making angle with the positive axis, it can make angle somewhere 3 pi by 4. This could be 3 pi by 4 or this could be pi by 4. So two angles are possible. Got it? So direction ratios, what happens is that cos alpha, cos beta, cos gamma, it is giving some value. For example, it is giving some value L, some value M, and some value N. So what will happen? We can say that L by cos alpha equals to M by cos beta equal to N by cos gamma. So here it will be equal to somewhere lambda because they are collinear. So here L, M, N are direction ratios. Okay, so this is done. Again we will have few questions on that. Okay. 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 So we'll proceed with this question. If the direction ratios of two lines are given by mn, lm, 4nl plus 3lm equal to 0 and l plus 2m plus 3n equal to 0, then find the direction ratios of the lines. Okay, so what will happen? We know that l square plus m square plus n square will be 1. This is always known. Okay, when if it is a direction ratio, it is always known. Now we have first equation is this, second equation is mn 4nl plus 3lm which is equal to 0, and third thing is that we have l plus 2m plus 3n equal to 0. So 3 into, okay, we'll have 3 into, we'll put from here we can get 2m plus 3n equal to minus l. So in place of minus l we'll put this value. So we are getting mn plus 4n. In place of minus l we are putting 2m plus 3n, and we have 3m. In place of l we are putting minus 2m 3n, and this is equal to 0. If we solve it again, we have mn 8 mn 12n square minus 6 m square minus 9 mn equal to 0. If we solve it, we are simply getting this and this cancel. If you see here, this, this, this is getting cancelled. Okay, that's good. We are getting 2n square equal to m square. So m is equal to plus minus root 2n. Okay, now what? Now we'll put, now we know that we got m and n, and we got m and n. We have to find L. So L is equal to minus of 2m plus n. So n is m by plus minus root 2. So L could be, or we write minus plus minus 2 root 2 n plus n. So L is minus 2 root 2 plus 1 n, or minus of minus 2 root 2 plus 1 n. Okay, this is what we got. Now we got L in the form of n, m in the form of n. If we substitute everything in one equation, we have L square could be 2 root 2 plus 1 whole square, n square, m square is 2n square, n square is n square, which is equal to 1. If we solve it, we'll get n square 9 plus 4 root 2 plus 3 equal to 1. So I think we are getting some really typical value. So n could be plus minus 1 by root under 12 plus 4 root 2. So if you got n, you got m, and you got L. Similarly, we can put minus 2 root 2 plus 1 in this place. So we'll simply get n equal to plus minus 1 by 12 minus 4 root 2. That's all. So you got n. Now in the place of n you put here, you got m, and you will get L also. So we got the direction ratios. It was really a bit rough calculation. Now we are proceeding ahead, okay? A plane intersect coordinate axis at a point 2 comma 0 comma 0 0 comma 4 comma 0 0 comma 0 comma 6. O is the origin. Then find the direction ratios of line joining B to the centroid of the face ABC. B joining centroid of face ABC. So we know that we are simply given that. Let's wait. It is better if we have geometry. Why don't we use them? Yes, coordinate axes are given, and in coordinate axis we have like this, a plane is intersecting like A, B, C. So coordinate is all about visualization. Okay. So centroid is somewhere here. So if x is 2 comma 0 comma 0, b is 0 comma 4, c is 0 comma 0 comma 6. So centroid is somewhere 2 plus 0 plus 0 by 3 in triangle. We know through from straight line 0 comma 4 comma 0 by 3 comma 0 plus 0 plus 6 by 3, which is equal to which is equal to 2 by 3, 4 by 3, 1, 2, 2, 3, which is 2. Okay. Now direction ratios of line joining B vertex and centroid. So B to centroid we are coming, isn't it? This is centroid, capital C. So we are simply finding BC vector and we are trying to find centroid. We are trying to find direction ratios. So in this type of question, this is 2 by 3, 4 by 3, 2 minus 0, 4, 0, 2 by 3, 4 by 3 minus 4. It is 4 by 3 minus 4 is 12 minus 8 by 3. And this is 2. So we got BC vector as 2 by 3 I cap minus 8 by 3 j cap plus 2 k cap. Now we have to find the direction cosine. Now while finding direction ratios, we simply have 2 by 3 upon, this is I cap, root under magnitude of that 2 by 3 whole square plus 8 by 3 whole square plus 2 square. First we'll find only this one, okay, and then whatever value we are getting. 4, 68 by 9, 68 by 9 plus 4, 68 plus 36, 104 by 9. So we are getting 2 by root 104 minus 8 by root 104 and 2 by root 104. If we multiply 2, 3, 3, we are getting 2 into 3, because if you remember it is 104 by 9. So 3 3 cancel, 3 3 cancel. So this is 6 upon root under 104. So this is its direction ratio. This is very interesting question, okay? If lines has direction cosine this and this, and they are perpendicular, okay? So we'll take some pause. I would suggest if someone who is looking this question, try this question, okay? Our aim would be that in place of any of the variable L, we'll try to substitute it. Okay. So if you want, I just wanted to continue. It is AL plus BM plus CN is 0. So what will happen? Can we say that L equal to, we'll send everything that side, minus of BM plus Cn upon A. We got this. Now we'll put this thing in this equation given. So we have F Mn Gn. L is minus Bm plus Cn upon A plus Hm. L is minus of Bm plus Cn upon A. It is equal to 0. Let's take something common. We have A F M N minus B G M N minus C G N square H M square minus H C M N. So we can say that we have BH M square CGN square plus MN BG plus HC minus AF equal to 0. Now what to do? What to do is that if you see in this equation, if we make a quadratic in n by m, we are getting product of the root, which is BH by CG. This is M1 by N1. M1 by N1. What is this? Okay. Wait. So if we make a quadratic in n by m, so CG will go there. So can we say BH by CG should be the product of the root N1 by M1 into N2 by M2? Can we say that? We can say this, yes. Similarly, okay. Similarly, wait for a second. This is a direction question, yes. Similarly, what will happen when we will take in place of L, in place for L we made this thing, for M we'll make something different. For M will make minus of AL plus CN upon B. So when CG, CG, okay. So when we'll do this thing, okay, we'll get something equation in L and N, okay, N1, L1, like that, okay. Okay, what will happen? We'll get like that. If we try to solve, let's solve it first, okay. It is better to solve only. Oh, it will go longer, okay. So we have FMN, yes, F minus AL plus CN upon B M into N plus G NL plus HL. In place of M we are putting minus of AL plus CN upon B equal to 0. If we try to solve it, we are simply getting BGNL. So we'll see just the coefficient of L square, which is minus HA L square. Okay, it was not minus. So minus HLA square, and the coefficient of N is minus FC B N square, and whatever will get NL coefficient, okay, that some coefficient multiplied with this, that we don't care. So product of the root will come out to be FCB. This is also B, yes. So we got product of the root like N1 L1 into N2 L2 to be HA by FC. HA by FC. So if you see that HA by FC, so B by G, we are getting, A by F we are getting. Similarly, when we go N1 L1, we'll go N1 N2 M1 M2 L1 L2, okay. So what we say, H by C is same in this also, yes. So we are getting B by G. So M1 L2 divide. So for M1 L1 L2 we are going to get, so N1 L1 M1 M2 and N1 N L1 N2, okay, whatever. No, we have to find that N1 M2, we have to find the value of M1 M2 N1 N2 L1 L2. This is what we have to find, okay. What is that value that we have to find? No, that value is 0. It is given that the product of the roots are 0. This is given. So we got M1 M2. So we can say that M1 M2 is C by H N1 N2 C by H N1 N2 into what? N1 into C by H N1 into G by B. Yes, and we can say from here that L1 L2, from here we can say, okay, L1 L2 is F by A, C by H, N1, N2. Now what will happen when we'll put everything in this equation? So and in M1, M2 we'll take N1, N2 common, and we are left with G by B, C by H, G by B, A by F, C by B, F by A, plus H by C equal to 0. So can we say that can we say that the given equation is equal to 0? This is simply we are saying. So I think the value is 0. Okay, so n1 n2 we got the common, we'll send n1 n2 this side, so we got the given value equal to 0. So this is done, and I wanted to delete, it is not deleting. Okay, so we got the answer. Okay, and we wanted to just color it a bit by using few drawings. We wanted to color it. Okay, so m1 m2 came out to be this, l1 l2 came out to be this is this, and m1 m2 will come out to be something, but we don't require here. And one relation is this, and when we kept everyone together we got this, and this is the answer. This is the answer. So the value is equal to 0. Got it? So good question, IIT advanced level question. So I tried to take this in class. Okay, so now we are moving to foci of a plane. Okay, eccentricity is given, then directrix we have to find. A plane is this. So what happened, this question is using the concept of direction ratio, and that is why I took this in the class. So let's take, this is a plane. A plane is this. So in this we have 2 point given. This is the point, this is the point, 2 points given. If eccentricity is, so we know that this distance between two foci, so two foci is somewhere 2AE, where we have 2A and eccentricity is given as 3 by 5. So the distance, if you calculate, it is root under 54 into 2. 54 minus of minus 54, which is 54 into 2 whole square, plus 18 minus of minus 18, which is 18 into 2 whole square, plus minus 27 minus of 27, 27 into 2 whole square. So we are getting somewhere 6a by 5 equal to, we'll take 2 square common, we got 2. We got that 9 square common, 9 here. So this is 9 into 18. So this is 36 plus 4 plus 9. I think we are getting 49. So it is 2 into 9, 49 root under is 7. So 6a by 5. If you see further, it is 9, okay? 6 3s are 18, 21. A equal to 21 into 5. If you do the calculation, 6 3s are 18, 7 3s are 21, 21 into 5 is 105. Okay, so we got 105. Now what? We have to find the equation of directrix. So if this is a line with focus this and ellipse, this is ellipse, yes, ellipse is like this. Directrix will be at the point a by e comma 0. It used to be normally like that, okay? And it used to be this side, it will be at minus a by e comma 0. If it is a like a 2D plane, it will become a by e comma 0 like that. So what will happen? The distance will become 2a by e. So we have to find in the form of point. We have to find in the form of point. So how the direction cosine will work here? We know the equation of line. Okay, we know the equation of line that we can know. Equation of directrix. Okay, we have to find the equation of directrix which is perpendicular. So what will happen? It is perpendicular to the line, isn't it? So when it is perpendicular, so it will lie in the line itself, and we are given with the equation of plane. Okay, I think this will come in fourth, fifth lecture. I think it is related to direction question. We'll have to think on it. Okay, let's wait to and think. So this will come out to be this and this. Okay. Mm-mm-mm-mm-mm-mm. So we can say that midpoint will be 0 comma 0 only. I think in this, if you see, the midpoint is 0 comma 0 comma 0. So midpoint is 0 comma 0 comma 0 only. So a by e and minus a by e are this that side. That we can confirm, isn't it? A comma 0. Yes, I have and having cold. Okay. So we will consider this question. I think after this question, we have few more topic. Okay. So we'll come to this question. Let's wait for some time. Okay. We'll start solving this question. Okay. The direction question of line bisecting angle between the lines. Okay. So what will happen? We are given with a line. We are given with a line which has L1 I cap plus M1 J cap plus N1 K cap. Okay. and we have second vector as L2 I cap, M2 J cap, N2 K cap. Okay, N2 K cap. So we have N2 K cap. Okay, so the angle between these lines are theta. Okay, so find the angle bisector. The direction cosines of line bisecting the angle. Okay, so if you see that in angle bisector, if you remember in straight line, we used to go L1, M1, N1 plus L2, M2, N2. If we divide it by root under L2 square, M2 square plus N2 square, this is 1, and similarly this is 1. Okay, the modulus is 1. So this is one of the bisector. So bisector 1, bisector 2, so angle between them is theta. So one is this bisector. So this bisector will come in between and other bisector will go outside. So this is our perfect bisector that we are looking for. So we are not looking for this bisector. We are not looking for this bisector. We are looking for this bisector. So we got B1 equal to L1 plus L2, M1 plus M2, N1 plus N2. So we have to find the direction cosine of this thing. So direction cosine is what? L1 plus L2 upon mod value of L1 plus L2 whole square, M1 plus M2 whole square plus N1 plus N2 whole square. So this will come out to be somewhere L1, L2 is already there. This is the game for this one. So if you see, it will come out to be, let's take white, okay. L1 square, L2 square, 2L1, L2, M1 square, M2 square, 2M1, M2, N1 square, N2 square, plus 2N1, N2. So if we see L1, M1, N1 is 1, L2, M2, N2 whole square is 1. So this is simply what? L1 plus L2 is there. This is 1, 1, 2 plus 2 time of L1, L2, M1, M2, N1, N2. So if you see, if you take dot product of that, it is what? L1, L2, M1, M2, N1, N2 is with the modulus of L1 I cap, M1 J cap, plus N1 K cap into L2 I cap, M2 J cap, plus N2 K cap cos theta. So we know that this modulus are 1, 1. So can we say this value is simply cos theta? So this is simply 2 cos theta, and if you find it, if you find this value, we are simply going to get L1 plus L2 upon half angle formula. It is 2 cos theta by 2 m1 plus m2, 2 cos theta by 2 n1 plus n2, 2 cos theta by 2. So these are the direction cosines of the angle between them. Okay. So now we are moving to again next question, and after that we'll reach to fourth lecture. Okay. Acute angle between this and this, where L, M, N are roots of this thing. Okay. So what will happen? We can simply say that L I cap, M J cap, and K cap in dot M I cap and J cap L K cap is mod of this thing, which is L square M square N square M square N square L square cos theta. So we know that L square M square N square are 1, or we don't know this thing. Okay. No, we don't know this thing. So we know only this thing, that this is LM MN NL upon L square M square N square is equal to cos theta. That much we know. Now what will happen? We have to find acute angle between this. So product of the root taken 2 at a time is plus minus plus. So this is minus 4, and in bottom L square M square N square, we should add 2 LM 2 MN, like that we have to add. Okay. 2 LM 2 MN 2 NL, and we have to subtract 2 LM 2 MN 2 NL, and this is cos theta. If we see it further, cos theta is equal to minus 4 upon, this is L plus M plus N whole square, which is what? Which is 1 square minus 2 time of LM MN NN is minus 4, which is minus 4 by 9. Then they told that the acute angle. So cos theta is coming negative. That means it's a obtuse. So acute will be theta. So cos theta is 4 by 9. You can say it. Okay. It is coming obtuse. So acute will be like, it is pi minus theta. That will become pi theta. Theta. That's all. Okay. We are done with this. Now we are going to this our previous question. Okay. So this is the fourth lecture, the third lecture end. Okay. What will happen? In this question we came, yes, we got a value, we got the equation of line. Hmm. Okay, okay, okay. The distance between this and this will be 2a by e. So 2a by e, which is what? 3 3s are 3 5s are 70, 350. Okay. Now what will happen if you go through equation of line? We know that one point is 0 comma 0 comma 0, and slope is slope is minus 54, minus 18, 27. So we can simply say that we take 9 common. So we got lambda minus common and minus 9 common. 6, 3, minus 3, minus 6, 2, 9 6 are 9 2 are 9 3 are. Okay. So this is the point we got. So when we'll try to find point on this line, it will be 6 lambda, 2 lambda, minus 3 lambda. And this is going to be opposite of this one. So this point will come out to be minus 6 lambda, minus 2 lambda, and 3 lambda. And we know that the distance between them is this thing. So this is root under 12 lambda whole square plus 4 lambda whole square plus 6 lambda whole square. If we see, it is 350 whole square equal to lambda square 144 plus 16 plus 36. It is what? 160, 196. Okay. So lambda equal to 350 upon 14. So it is 750 ja, 72 ja, so 25. If you try to find the point, it is 150, 50 minus 75. So equation of directrix. Equation of directrix. So we got the point. We got the point. Okay. Now equation of directrix will be perpendicular to that. If we take the slope of this to be direction ratio of the perpendicular, we have to find now equation of perpendicular line, because directrix is going to be perpendicular. Okay. uh, uh, uh. How to take this point on the line? We got this point, that is our issue. So find the equation of directrix. So which type of equation? Plane equation, line equation. What is the equation of line? Okay. So what will happen? Yes, we'll take the direction cosine to be L M N. Okay. So what will happen? The line equation will come out to be x minus 150 upon L, y minus 50 upon M, and z plus 75 upon n. So this is, it's a direction cosine. So if you multiply L with this, it will come out to be 0. So 6L plus 2m minus 3n is equal to 0. Okay, it is equal to 0, and L square plus m square plus n square is again 0. So L square plus m square plus n square is equal to 1, and 236 is also perpendicular to LMN. So 2L plus 3m plus 6n is equal to 0. So if you try it solving, okay, if you ask me how to solve, multiply this line with 2 and add with this. So when we multiply 2 and add, we got 14. I'm just writing in short, okay, 14L plus 7m is equal to 0. So 2L equals to minus m, and minus when we put minus m equal to 2L, okay, in this equation, first equation, so minus m equal to 2L, that means minus 4L. So 2L equals to 3n. 2L equals to 3n. We got it. Now, when we put L, M, N in L square, M square, N square, so L square is L square, M square is 4L square, N square is 4 by 9 L square, which is 1. So what will happen if we calculate? It is simply 3 by 7. So we'll get L equals to plus minus 3 by 7. So M equal to minus plus minus plus 6 by 7, N equal to 2 by 3. So minus plus 2 by 7. So we'll put here in the place of L, M, N, and we'll get the answer. That's all. Done with the good question. Now we are moving to lecture 4. So we are moving to lecture 4, which is distance between two lines. Okay. Direction question done. Distance between 2 points for a while. Direction question done. We are taking a break. Distance between 2 points for a while. For 1 second, we are taking a break. Come in 5 minutes, okay? So yes, we will continue right now, just right now. Okay. Okay. Let's continue. Okay. Distance between 2 points. So a line is given. So why we have taken this thing, this topic? In straight line, we already studied that if we are given x1, comma y1, comma z1, and this is x2, comma y2, comma z2. Yes. Then what is the distance? So what will happen? I will derive it. Okay. Let's derive it. Let's derive it. Okay. We'll derive it. This is a coordinate axis. This is a coordinate axis. What will happen is that this point will fall here and it will be like this. It will be right like this. Okay. Okay. So what we will consider is that uh no, this is a point. Yes, we took this point. So this point will fall here on the ground. Yes, and it will have something per distance like this, distance like this. Okay. If you see the distance, this joining this point and this point is distance joining this point and this line. Yes, can we say that? So if we see, if this is xz plane, if this is xz plane, this value will come out to be x square plus z square root under. So this line will be coming out to be root under x2 minus x1 whole square plus z2 minus z1 whole square. Got it? And now we have to find this distance, and this much point will come out to be y2 minus y1. So according to Pythagoras theorem, Pythagoras theorem will do this length is AB. AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this length square is x2 minus x1, z2 minus z1 whole square, and this length is y2 minus y1 whole square. So can we say that AB is equal to root under x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is what we have to know, okay? This is what we should be knowing now onwards. We got the proof, and now onwards we should be knowing these things, okay? So this is what now move to the question. So locus of a point which is equidistant from this and this. So locus of a point which is equidistant from this and this. A point is given. If we are telling a locus, we'll put it P. We'll keep x, comma y, comma z, and this is a point A. 0, comma 2, comma 3. We'll keep a point B. 2, comma minus 2, comma 1. So we are given that AP square is equal to PB square. They are equidistant. It is given in the question. We'll have simply x minus 0 whole square, y minus 2 whole square, z minus 3 whole square is equal to x minus 2 whole square plus y plus 2 whole square plus z minus 1 whole square. In this type of question, we will never open square. Okay, we will shift everything this side on that side. So we'll get a square minus b square plus this square minus this square plus z minus 3 whole square minus z minus 1 whole square, which is equal to 0. Now a square minus b square is what? A plus b. A plus b is what? 2x minus 2, and a minus b is 2. Here a plus b is what? 2y. A minus b is minus 4. Here a plus b is what? 2z minus 4. A minus b is minus 2. If you see, we can take 4 common in every side. We'll get x minus 1 minus 2y minus z plus 2 equal to 0. We are getting x minus 2y minus z equal to not plus 1 this side only. So this is the equation of locus. This is the equation of locus. Done with the question. So this distance, they are equal. They are equal, okay? Next question. Okay, we have next question also. Okay. Next question. Okay. Find the locus of a point which moves such that the sum of its distance from this point and this point is constant. Okay. So similar type of question we got from earlier. Yes. So this is a point x comma y comma z. This is the point A, 0 comma 0 comma minus alpha. This is the point B, 0 comma 0 comma alpha. So sum of the distance. We are told that PA plus PB is some constant. Okay. PA is what? PA is PA is x square y square z plus alpha whole square. And PB is what? X square y square z minus alpha whole square, which is constant. So this constant is not known and everything is known. Okay. The locus of a point that which moves such that the sum of its distance from point A and B is constant. So we know that there is a case of ellipse. Okay, there is a case of ellipse. If we see in ellipse, okay, in ellipse what happened? If this is a focus and this is a focus, the distance of this, the sum of their distance is equal to 2a, is equal to 2a, which will be like 2 alpha. So in this question, what was the question, which is really difficult to know? In ellipse it is the same. So we'll take this question. It is normally that, okay, and we have to square it and solve it. Okay, what we can say is that this should be constant, isn't it? That means if we put the any value on x and y and z, it should be the same. And if we put 0, we are getting alpha alpha, that is 2 alpha. Then this is the locus. Got it? On putting x, y, z equal to 0, 0, 0, then what will happen? This will come out to be root under alpha square, which is 2 alpha. So this is the locus. So we have to normally find the value of constant. So the value of constant is this. On putting x equal to 0, y equal to 0, z equals to 0. That's all. Next question. One of the vertex of a cuboid is this. Okay, good question. IIT Advanced previous year question. Let's tackle it. The vertex, okay. First we'll draw a coordinate axis, okay. X, Y, Z, okay. Now what? Now vertex is given as, if it is X, this is Y, this is X, this is Y, and this is Z, okay. So it is 0, X is 0, Y is 2, Z is minus. So this is the point lying in xz plane, okay. And if one of the vertex from, so one of the vertex is this, and edge of one of the vertex are along positive x-axis, okay. Positive x, maybe this, maybe from this, or maybe from the beginning, and one is along y-axis, maybe this, and one is along z-axis. Edges are, and the edges from vertex, one of the vertices of the cuboid is given, the edges from this vertex are along, okay. So the edges from this vertex are along positive x-axis, positive y-axis, and x-axis, y-axis, and positive z-axis. No, x, z, y, positive y-axis, maybe this way, okay. So this is the way, okay. And are of length 2, 2, 3 respectively. So now it's time for 2 to 3, okay. So in x we have 2. This is 0, 2, minus 1. In x we have 2. So 2, 2, minus 1. In y we have 2. So 2, 4, minus 1. In z we have 3, 0, 2, 2. Okay. Find out other vertices. Okay. Now we have to find out other vertices. So let's join it. Let's join it. Let's join it. Let's join it. This is the cuboid, yes. If this is 2, this is known. This point is coming out to be somewhere. This is parallel to xz plane. So, Y is same, Z will be from here, Z is 2, and Y will be from here, 2. Similarly, these two are joining, yes. So if you go, so from here we simply move in x direction by 2. Simply we'll move from here. So if we put it a nomenclature, A, B, C, D, E, F, G, H. So A is 0, 2, -1. B is 2, 2, -1. C is, so C is like, we are moving from this point, we are moving three direction in, 3 in Z direction, which is 2, 2, 2. D is, we are moving three distance in Z axis. So we have this point, we are moving like this. So 0, 2, 2. Now, if we find E, from the given point D, we are moving two direction in Y. That means 0, 4, 2. If we see out F, from A, we are moving two direction in upward direction. So 2, 4, -1. If we see G, we are moving two direction upward. 2, 4, -1. If we see H, two direction from C, which is 2, 4, 2. Got it? All the vertices got? So that the points are the vertices of a square. Vertices of a square. Okay, how to show the vertices of a square? So that the points are vertices of a square. Okay. Uh, 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 Should we plot it? No, 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 no. Slope of this is perpendicular to slope of this one. Yes. Let's plot it on coordinate axis. We'll have to see how it is coming. Okay. First we'll put the point, isn't it? 0, 4, 0, 4, 1. 0, 4, 1. 2, 3, -1. 2, 3, -1. 4, 5. Again 4, 5 here. 4, 5, 0. 2, 6, 2. 2, 6, 2. So can we do like this? We join this line, this line, this line, and this line. So 1, 2, 3, 4 sides. And these are the part of a square, okay? vertices of a square. So can we prove it as a collinear? I got the hint. So we'll say a vector to be 0, 4, 1, b vector to be 2, 3, -1, c vector to be 4, 5, 0, d vector to be 2, 6, 2. So we'll find AB vector, which is B vector minus A vector, 2, -1, -2. AC vector, 4, 1, -1. AD vector, 2, 2, 1. Now if we do box product, AB cross AC dot C, 2, -1, -2, 4, 1, -1, 2, 2, 1. Do you want to do some row operation? Uh, uh, uh. So let's directly open it, okay? 2, 1 plus 2, plus 1, 4 plus 2, and -2, 8 minus 2. So if you see, it is equal to 6 plus 6, 12, and 8 minus 2, 12 minus 12, 0. So this is 0. That means they are coplanar. So determinant equal to 0. They are coplanar. Move to the next point. So what will happen? Locus of a point. So if it is saying locus, we'll take P as x comma y comma z, and AP square. So AP square will come out to be x minus 2 whole square, y plus 1 whole square, z minus 3 whole square, and BP square is equal to x plus 1 whole square, y plus 2 whole square, plus z minus 1 whole square. So AP square minus BP square is 20. So AP square minus BP square will do. So A square minus B square. A plus B into A minus B. Second, A plus B into A minus B. Third, A plus B in upon and into A minus B, which is equals to 20. So that's the locus. We got something in x and y. Minus 6x plus 3 minus 2y minus 3 minus 4z plus 8 equal to 20. If you see further, it is 3 3 cancel, 8 will come this side. It is 12. 12. So we'll get minus 3x minus y minus 2z equal to 6. And if you say no, on the same side, it is 3x plus y plus 2z plus 6 equal to 0. So this is the answer. That's all. Okay. So we'll have let one vertex of cuboid whose faces are parallel to coordinate plane. This coordinate plane is 1, 2, 3. Okay. Okay. So let one of the vertex of cuboid. So let's continue. Uh uh uh. Okay. So we'll go with the coordinate. Okay, we'll go with the coordinate axis. Let one vertex of a cuboid. So this is a three-dimensional. Okay. Mm-hmm. So let one vertex of cuboid whose faces are parallel to coordinate plane is 1, 2, 3. So coordinate plane is there. With if midpoint of one of the edges is 0, comma 0. So one of the edge is like this, whose midpoint is 0, comma 0. Now we can have structure down and up. If we go down, 1, comma 2, comma 3 will not come. So we'll have to move up. Okay? And we'll go like this. We'll join them. We'll again go down, connect them, go this way, go this way. So this is a cuboid, our formed cuboid. Okay? Midpoint is 0, comma 0, comma 0, and one of the vertex of cuboid is 1, comma 2, comma 3. So let's take it as 1, comma 2, comma 3. Okay? So from here, if you drop here, it will be 1, comma 0, comma 3, because it is x, y, z. So this will come out to be 0, comma 0, comma 3. And if it is 0, comma 0, comma 3, this point will come out to be 0, comma 0, comma minus 3, and this point will come out to be minus 3 is already there. This is xz plane. So x is also same. Y is 0. If you come here, uh, x, z are same. Y, x, z are same. Y will vary. So 1 comma 2 comma 3 is this. So in this y is 2. Okay. And in this case we have yz plane. So in yz, if we take this thing on yz, x will be 0. And we have y z. If we come this side, x is 0, y is same, z is positive. So I think we got all the point. So the length of this is, we are getting the length of this as 6. The breadth of this is, we are getting 1. The height of this, we are getting 2. So first question, total surface area. Total surface area of cuboid is 2 LB plus BH plus HL. So 2, 1 into 2, 1 into 6, 2 into 6, which is 12 plus 6, 18, 18 plus 2, 20, which is 42. Length of body diagonal, length of body diagonal. So we'll choose this point, and this point. So diagonal is what? Root under 1 square, 2 square plus 6 square. So this is root 41. That's all. Now we are moving to section formula. Now we are proceeding to section formula. Okay. So in section formula, what will happen is that section formula is similar to the way we studied in straight line. It is similar, okay? So what will happen? We are going with section formula. One is vectorly. Okay. So in section formula, if we are doing Cartesian wise, in Cartesian form. Okay, if a point is A, x1 comma y1 comma z1 comma, and then second point is x2 comma y2 comma z2. These are the point. So a point divides into m is to n ratio. If C divides in m is to n ratio, then C will be mx2 and x1 by m plus n, and this will be my2 plus ny1 upon m plus n, and this will be mz2 plus nz1 upon m plus n. So now what? We got this Cartesian form. Second, we have vector form. Vector form, then what to do? If a vector is given with like I cap, 3j cap, 3k cap, and we have to find a vector which is dividing this line into 1 is to 2 ratio. Can we say this part is 1 into lambda plus 2 into lambda equal to 1? Can we say lambda equal to 1 by 3? So this part will come out to be what? 1 by 3 times of 3i cap, 3j cap plus 3k cap, and the other part will come out to be 2 by 3, 3i cap, 3j cap, 3k cap. So that's all. So this is A, C, and this is B. So this will become AB vector, and this will become BC vector. These concepts are useful. Don't forget this. Okay, let's proceed. Have some question. Okay. So everyone welcome. This is one shot in vector 3D. So if a point PQ, RS are respectively, then PQ and RS intersect. Find the point of intersection. Okay. Find the point of intersection. a line is this, a line is this. Okay. No, no, no. It is for JEE mains. If you see the topic, it is written JEE mains. JEE mains plus J advance. Okay. JEE mains J advance 2025 one shot in vector 3D. Samartha good too. This is for JEE mains J advance both. Okay. And if you study from here, you will be able to solve for board also. Definitely. Okay. So we have a point P. Point P is 4 comma 7 comma 8. Q is minus 1 comma 2 comma 1. R is 2 comma 3 comma 4. S is 1 comma 2 comma 5. Okay. Then we have to find point of intersection, so that first they are intersecting. So what we can do is that we'll consider that they are dividing it into lambda is to 1 ratio. Okay. And they are dividing in the ratio k is to 1. So let's find the point of intersection. 4rs 4rs. Okay. If we do lambda is to 1, you will get the point to be lambda 1 lambda plus 2 by lambda plus 1. You will get 2 lambda plus 3 upon lambda plus 1. You will get 5 lambda plus 4 upon lambda plus 1. 4 pq 4pq, you will get minus k plus 4 upon k plus 1. 2k plus 7 upon k plus 1. K plus 8 upon k plus 1. So my saying is that these 2 points should be equal, isn't it? So we'll have lambda plus 2 lambda plus 1 equal to minus k plus 4 k plus 1. Let's cross multiply. If we cross multiply, we are getting k lambda 2k plus lambda plus 2 minus k lambda plus 4 lambda minus k minus plus 4. If you solve it further, if you see, we are getting two variable and we have three equations, so we can simply find it, isn't it? So we are getting 2k lambda plus 3k minus 3 lambda equal to 2. One is this, and then second second we have 2 lambda plus 3 upon lambda plus 1 equal to 2k plus 7 upon k plus 1, which is 2k lambda 3k plus 2 lambda plus 3 equal to 2k lambda plus 7 lambda plus 2k plus 7. So if we solve it simply, 2k lambda cancel, we are getting k minus 5 lambda equal to 4. Okay, we are getting this thing. What can we say is that for node going more longer, we can put k in the form of lambda. K equal to 5 lambda plus 4 in the given equation. So we can get 2 lambda into 5 lambda plus 4 plus 3 time of k, which is 15 lambda plus 12 minus 3 lambda equal to 2. If we say it is 10 lambda square plus 8 lambda 15, 23 lambda minus 3, 20 lambda, 8 plus 15 minus 3, and this is plus 10. If you will see, it is simply lambda plus whole square equal to 0. So lambda is minus 1. So lambda equal to minus 1, and when lambda is minus 1, k equal to minus 1. So this is the question it is coming. Okay, let me check once. No, it should be lambda equal to 1, k equal to 1. Okay, there's something garbadi. Okay. So lambda equal to minus 1. Ten lambda square, 8, 15. So we got some mistake. You should be checking the mistake. We should be getting lambda equal to 1 and k equal to 1. So lambda is 1, k is 1. And if you got that thing, the point of intersection will come out to be 3 by 2, 5 by 2, 9 by 2. These are the points. Okay, just check it once. Find the ratio in which YZ plane divides the line joining A and B. So let's take a plane is dividing the line joining 4 comma 3 comma 5 and B 7 comma 4 comma 5 in ratio lambda is to 1. So in YZ plane x coordinate will be 0. So if we find this point x coordinate, it is what? 7 lambda plus 4 upon lambda plus 1 is equal to 0. So lambda is minus 4 by 7. So the ratio is what? Minus 4 by 7. That's all. Moving ahead. Okay. Proceeding ahead. Find the coordinates of foot of perpendicular drawn from point A on the line joining this. Okay. So using section formula, how can we solve this question? This is a doubt. So what will happen? We'll take a point B 1 comma 4 comma 6. We'll take a point C 5 comma 4 comma 4. We took a line joining this. Okay. From a point A 1 comma 2 comma 1, a perpendicular is drawn. We have to find the foot of perpendicular. We'll consider that foot of perpendicular is dividing this point into 1 is to lambda is to 1 ratio, and that point is D. So D point will come out to be 5 lambda plus 1 upon lambda plus 1, 4 lambda plus 4 upon lambda plus 1. Okay, we got simply this point as 4. Okay, and this as 4 lambda plus 6 upon lambda plus 1. What will happen? This point D we got. Now we'll find AD vector. So AD vector is 1 minus 5 lambda plus 1 upon lambda plus 1, comma. This is 4. 2 minus 4 is minus 2. And this is 1 minus this thing. 1 minus 4 lambda plus 6 upon lambda plus 1. Okay. So this is simply lambda plus 4. So minus 4 lambda plus 3 upon lambda plus 1. This is minus 2. This is what? Minus 3 lambda minus 5 upon lambda plus 1. This is AD vector. Now we'll find BC vector. BC vector is what? 5 minus 1 4. 4 minus 4 0. And 4 minus 6 is minus 2. If we what will happen if we will do? If we do AD vector dot BC vector, it should come out to be 0. So from here we can get lambda. So it is what? 4 into minus 4 lambda plus 3 and this is minus 2 into minus 3 lambda minus 5 equal to 0. So we'll have simply minus 16 lambda plus 12 plus 6 lambda plus 10 equal to 0. So we'll have 10 lambda equals to 22. So lambda equal to 11 by 5. So now we got lambda equal to 11 by 5. Now we can simply find D by putting lambda equal to 11 by 5. So if we should put 11 by 5, it is 12 upon 16 by 5. And this is 11. 64 by 5 upon 16 by 5. And this point is 74 by 5. And this is 16 by 5. So we'll simply get it as 4 threes are 4 fours are 4 threes are 4 fours are. So 15 by 4 4 37 by 8. So this is the point. We got it. This is the foot of perpendicular. This was the lambda. Let's move. Now this is the time for next question. Okay. So lecture 4 is a bit lengthy. Okay. We have 8 questions to complete lecture 4. Okay. We'll take 5 minutes of break. Okay. We'll take 5 minutes of break. Let's have a break time. So hello everyone, I am back again. Okay, so we'll proceed now. In a triangle ABC, okay, in a triangle ABC, so let's make a triangle. D and E are points on BC and AC. In a triangle ABC, a triangle is given ABC. D and E are the point on BC and D, okay, and E are the point on BC and AC such that BD divide DC. BD equal to 2DC. BD is BD by DC is 1 is to 2 is to 1. So this is 2 is to 1. Yes, BD by DC is 2 is to 1. And AE by EC. AE by EC is 3 is to 1. Okay. PB, point of intersection of AD and BE. AD. AD and B. So P, B point of intersection of ADB. Then find BP by P. Okay. In this type of question, it is better. It is the best to take this as A vector, B vector, C vector. So D point will come out to be, so this is a position vector. Yes, D vector will come out to be 2C vector plus B vector upon 3. E back vector will come out to be 3C vector plus A vector by 4. Now BD vector, no, BD not. Now, no, what? Uh, uh, uh. So we got E vector. Now we'll consider that P vector is dividing this into lambda is to 1 ratio, and P vector is dividing it into K is to 1 ratio, K and lambda. So now what? Now P point will come out to be KD, 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 KD plus A vector upon K plus 1, which is also equal to K lambda E. plus A vector upon 4 lambda E plus B vector upon lambda plus 1. And one more thing, they are equal, they are same, so it's better to deal in this way. We are getting 2k upon 3k plus 1 C vector plus k upon 3 into k plus 1 B vector plus A vector k upon 1 is equal to 3 lambda 4 lambda plus 1 C vector plus plus lambda upon 4 lambda plus 1 A vector, and this is B vector upon lambda plus 1. This is it. So what will happen? We'll compare them. 2k upon 3k plus 1 is equal to 3 lambda 4 lambda plus 1. If we solve it, it's like 8k lambda plus 8k equal to 9k lambda plus 9 lambda. So we are getting k lambda plus 9 lambda minus 8k equal to 0. So this is the previous, like this is like previous question that we did. Okay, so this is what we got, one here. Second when we solve b and b, so we are getting k lambda plus k equal to 3k plus 3. So we are getting k lambda equal to 2k plus 3. So in place of k lambda, can we write 2k plus 3? So it is 9 lambda 6 lambda plus 3, which is 3 lambda minus 2 plus 1 minus 2k minus 2k plus 1 equal to 0. This is what we got. Okay, and then third equation, this was for b. In b we got this thing. Now if we go for c, we go for a. In a we are getting k lambda plus lambda is equal to 4 lambda plus 4, and k lambda is 2k plus 3. This is k lambda For A we are going 4 lambda plus 4, k lambda plus lambda. Okay. So k lambda is 2k plus 3. So 2k minus 3 lambda equal to 1. And we have 3 lambda minus 2k plus. Okay, it is the same coming. So P by, what is k is to 1? Yes, we have to find k is to 1. What is the value of k? That we have to find. Okay, so we got one equation this, one equation this. Now we have to find the value of k. So in place of lambda, can we put 2k minus 1 by 3 minus 2k minus 3 equal to 0. So we are going to get 2k square minus k minus 6k, that is minus 7k, and this is minus 9 equal to 0. So k is 7 plus minus root under b square. Okay, 4. This is 7 plus minus 11. So 18, which is 89 by 2, and second minus 1, minus 1. So 9 by 2 could be the answer. Minus 1 is external point. So P is dividing internally. So it's a 9 by 2. So the answer is 9 by 2. Okay. So let's move to next question. So see, section formula questions are how good. Yes, you can see that section formulas are good. So the vertices PQ and S of a triangle PQS have position vector P vector, Q vector, and S vector respectively. Okay. Okay. The vertices has this position vector. Find the position vector of P of a point T in term of PQS such that ST by TM is 2:1 and S is midpoint. Okay. So this is very simple question. So I think we are given 2 pages. So this is a triangle. We consider this as PQS. Okay. Position vector of P is what? P vector. Q is what? Q vector. And S is what? S vector. Okay. Those who are watching this online, don't worry. I will provide you all the PDF, all the solutions which I am doing right now. I will share this PPT with you all. So don't worry. Okay. So we are given that T is a point, T vector is a point position vector for capital T. We have to find that such that ST and TM ST. M is midpoint of PQ. Okay. So M is midpoint of PQ and we have ST is to TM. So T is somewhere here. We have to find the position vector of T. So this comes out to be simpler question. M point will come out to be P vector plus Q vector by 2 and ST to TM is 2:1, that means this is 1:2. So we can simply say T position vector of T will come out to be S vector into 1 section formula 2 into P vector plus Q vector by 2 upon 1 plus 2, which is S vector plus P vector plus Q vector by 3. And we know normally that it will be a centroid. If a point is dividing line joining median in 1:2 ratio, okay, then it's a centroid. So we simply got the centroid. This is a centroid. So this was for question 1. Now we are going to question 2. If the parallelogram PQRS is now completed, PQRS. So this is new point R, PQRS. Express the position vector of R in PQS. So we know that position vector. Okay. So if we write PR vector, this is what? PR vector. We can say that it is OR vector minus OP vector. Yes, we can say this. Now what will happen? We can say this. We have to write OR. We have to find OR vector. Okay. So we have to find OR vector that we don't know, and OP vector we know it's the P vector. And PR vector is what? PR vector is PS vector plus PQ vector. If you see that, okay, PS vector plus PQ vector. So it will come in this direction, and this direction. This will shift this way and you will get the resultant. So PS is what? P2S is what? S vector minus P vector. PQ is what? Q vector minus P vector. And if you go further, you can find that OR vector is simply S vector Q vector minus P vector. Got it? So we got OR vector. And we got T vector. Got it? move ahead. Now, so I think this is helping us, helping all of you who are online and who is going to see it later also. This will be going to help you all a lot. Okay. So now it's time for this question. ABCD is a quadrilateral. Okay. Wait a second. Let me see. So ABCD is a quadrilateral with AB vector equal to P vector, BC vector equal to Q, DA. Okay, all are given. If EB is the midpoint of BC, F is the point on C. So it's a use of section formula. Let's see it. Okay. Wait a second. Wait a second. I'm looking from which reason and religion this question is belonging to. Okay. Okay, let's proceed. No problem. We are expert already. It's a quadrilateral AB. Okay, AB, BC, AB, BC. There will be some D, and there will be like this. It's a quadrilateral. Okay. So A, B, C, D. AB vector is P, BC is Q, DA. A, B, C, D. Okay, D to A. The sense, you can come to know the sense. Okay, D to A is P vector minus Q vector. So P vector minus Q vector is D to A. Okay, E is midpoint of BC. So we know that, can we say that, okay, and F is the point on DE. F is a point on DE such that DF by DE is 4 is to 5. DF by DE. Okay, if DF by DE is 4 is to 5, I have to find the value of DF by FE. Okay, or we can simply write DF equal to 4 by 5 D. Let's find D. Okay, now, and so that AFC are collinear. Okay, so AFC lie on the same line. Okay, So see how to approach this one. If we so go like this, AB vector plus BC vector plus CD vector plus DA vector is equal to 0. We know all the vectors. We know AB vector, which is P. We know BC vector, which is Q. We don't know CD vector. We know DA vector, which is P vector minus Q vector. Can we say that CD vector is minus 2P vector? Okay, okay, we got CD vector. Now, E vector, BC, now BC vector, half of BC vector is EC vector. Can we say that? So, can we say that EC vector is Q vector by 2? Okay, that's great. So now, so now, in order to find, uh, 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 okay, we have to show that AFC are collinear. Okay, okay. We have to find AFC are collinear. We have to find AF vector is lambda time AC vector. This is our aim. Okay, this is our aim. Okay, so we will have to find AF vector. Okay, so first we will find DE vector. Okay, DE vector is what? DE vector is, or we say minus DE vector, that is ED vector. What is ED vector? EC vector plus CD vector. So EC vector is what? Q vector by 2, and CD vector is what? Minus 2P vector. Okay, this is ED vector. uh, uh, uh. So what will happen? AF vector is equal to ED vector we found. ED vector we found. FD vector is 4 by 5 times of Q by 2 minus 2B vector vector plus P vector minus Q vector. If we solve it further, we are going to getting 2 by 5, which is minus 3 by 5 q vector minus 8 by 5 minus 8 by 5 plus 5 minus 3 by 5 q vector. If you find AC vector, it is p vector plus q vector. So which is minus 3 by 5 time of AC vector. So can we say that AF vector is equal to lambda time AC vector, hence they are collinear. Got it? Let's move ahead. Okay, now we move to next question. LMN divides the sides BCCAAB of triangle ABC in the ratio this. This is the vector parallel of this thing. When K divides, prove that. Okay, prove that. Prove that. Okay, go with the drawing first. This is A, B, C. We'll consider this as A vector, B vector, C vector. L divide BC, and they are what? Oh, it is better if we take like this. It is better if we take like this. Okay, we are doing addition of parallelogram, isn't it? We are doing such question. We'll consider this as A vector, B vector, C vector. So point it in the form of 1:4. That means this is A vector by 5 and this is 4A vector by 5. So it's like normally A vector. M divides CA, C2A in the ratio 3:2. That means this part is 3 by 5 B vector and this part is 2 by 5 B vector. And N divides A to B, N in the ratio 3:7. That means A to B is 3:7. So it is 3 C vector by 10. This is 7 C vector by 10. Now AL vector. AL vector is what? AL vector is LC vector. No. AL vector is what? AC vector AC vector plus CL vector. So from so okay, if we take direction like, we should be first taking direction like, okay, we are taking this direction, for example this sense and this sense, okay. So AC vector is minus B vector and CL vector is minus 4A vector by 5. This is AL vector. Similarly BM vector. So BM vector is what? MA vector, B to M. We have to go from B to M. That means minus of AB vector and minus of MA vector, isn't it? So we are getting minus of AB is minus C and minus of MA is minus 2 by 5 B vector. CN vector, CN, C to N we are going, that means CA vector plus AN vector. So CA is B vector and AN is 3C vector by 10. So if we add all of this, AL vector plus BM vector plus CN vector, this is going to what? BB cancel. So we are getting 2 by 5 B vector minus 4 by 5 A vector, and we are getting minus 7 by 10 C vector. We are told that this is parallel to CK vector and K divides AB in the ratio 1 is to 3, A to B 1 is to 3. So there is a point K which will divide A to B in 1 is to 3. So okay, 1 is to 3. So this is C vector. So this will come out to be C vector by 4 and this will come out to be 3 C vector by 4. Okay. So CK vector, C to K vector, CK vector is AC vector plus AK vector. So AC vector is B vector and AK vector is it is CA vector. CA vector plus AK vector. So CA vector is B vector and AK vector is C vector by 4. Okay, okay. Okay. So I think we did some mistake in calculation. Okay. No, I am in Hyderabad side, so it's a normal weather. Okay, it's a normal weather this side. That is why there is no cold this side. In north, it is cold. Okay, so we got this point. Okay, and we got this point. There should have been some subtraction in A and B. Okay, so we'll see this later. Okay, let's move ahead. Okay, so that point these are collinear. Okay, and also in which ratio C divides AB. Okay, so V1, if you have any doubt, okay, you can just come to me and you can know. Okay, so A is 2 comma 3 comma 4, B is -1 comma 2 comma -3. We have to find C is -4 1 -10. So we have to find whether C is collinear to AB or not. So we'll take the ratio AC upon CB is in the lambda is to 1. Okay, in the ratio lambda is to 1. So the point of C will come out to be minus lambda plus 2 upon lambda plus 1, 2 lambda plus 3 upon lambda plus 1, minus 3 lambda plus 4 upon lambda plus 1. If we put it equal to minus 4, yes, so what the value we are getting? Okay, next weekend we are going with integration. Okay, this one vector 3D. Vector 3D also has 6 question weightage in JEE means J advanced per year. So kindly focus on this. Okay, lambda plus 2 equals to minus 4 lambda minus 4. If you see, we are getting 3 lambda equal to minus 6. So lambda is minus 2. If we put minus 2 in this, what are we getting? Plus 1. Yes, we are getting plus 1. If we put minus 2, we are getting 10. Minus 10. Yes, we are getting. Hence, they are collinear and the ratio is minus 2 is to 1. Got it? So that they are collinear and find their ratio. Okay. Now we have come to centroid. Centroid. Okay. This is a point A with x1 comma x2 x1 comma y1. Okay, comma x2, no, again x2 I wrote. Okay, see how is it going? X1 y1 z1, this point is B, x2 y2 z2, C point is x3 y3 z3. We have to find centroid. Centroid is the intersection of median. So if we find this point, okay, this take it as D. So D will come out to be x2 plus x3 by 2. This will come out to be y2 plus y3 by 2. And this will come out to be z2 plus z3 by 2. Okay. Now what will happen? We know that centroids divide the line joining A and D in the ratio 1:2. So by section formula, by section formula, we can do G. G could be 2 time of x1 plus x2 plus x3 upon 2 plus 1 time of x1 upon 2 plus 1, comma. If you see, this has simply come out to be x1 plus x2 plus x3 by 3. Similarly, when you do this thing and you solve this one, you are going to get y1 plus y2 plus y3 by 3. This is z1 plus z2 plus z3 by 3. So this is the centroid. Got it? Next, move further ahead. Centroid. So we got, based on the previous formula, we know that x1 plus x2 plus x3 by 3 will be 8 by 3. We know x1 x2, which is 4 plus 2 6 plus x3 equal to 8. So x3 is equal to 2. Okay. So this is first. Second, y1 plus y2 plus y3 by 3 is minus 1. We know y1 plus y2 is minus 8 plus y3, which is minus 3. So y3 is 5. Third one, z1 plus z2 plus z3 upon 3 is equal to 2. We got z1 plus z2 is 4 plus z3 equal to 6. So z3 equal to 2. Got it? So we got the vertex as x3, y3, z3. So we are done with this. Now move to Incentre. I will go through the proof of Incentre, okay? So stay ready to get the proof. This is the triangle. Okay. In center is intersection of angle bisector. Okay, that's great. So what will happen if this is A, this is B, this is C? This will, the length of this side is A, the length of this side is B, the length of this side is C. So if this point is x1, comma y1, comma z1, this is x2, comma y2, comma z2, and this is x3, comma y3, comma z3. Okay, so what will happen is that this side will get divided into C is to B ratio. Okay, so if you will try to find this point D, D will come out to be C time x3, B time x2 upon B plus C. Similarly, C time y3, B time y2 upon B plus C, comma C time z3, B time z2 upon B plus C. This is the point. And now what will happen? Now what will happen? From here, if you draw the angle bisector, this is the angle in center. Okay. So from here, what will happen is that the line joining this will get divided. Okay. And how will it get divided? So this is CB. So can we say this part is AC upon B plus C, and this part is BC upon AC upon B plus C. So this part is AB upon B plus C, AB upon, okay, and this is AC upon B plus C. So if we divide this line and this line, it will be in the ratio of AC upon B plus C is to C. That will be the ratio. And if you see further, it is A is to B plus C. So the ratio of this is A is to B plus C. So now E coordinate of E will come out to be coordinate of D into B plus C. Coordinate of D into B plus C, which is Cx3 Bx2 plus coordinate of A into A, which is Ax1 upon A plus B plus C, and similarly for everyone it will get repeated. So this is Cy3 By2 Ay1 upon A plus B plus C, and this is Cz3 Bz2 plus Az1 upon A plus B plus C. So we got this thing, isn't it? We got Incentre. Incentre we got. Now we have a question. Okay. We have a question. So we have a question now. A triangle vertex is given. You have to find the internal bisector of BAC meets BC at D. Then AD is what? Okay. This is A 5 4 6 B 1 minus 1 3 C 4 3 2. The internal bisector of BAC, matlab this is the line, okay? So this is the line and this is the angle internal bisector. Internal bisector of BAC meets BC at D, okay? Then find AD. The length of AD we have to find. So we can simply say that the length of this one, is what? 4 square plus 5 square plus 3 square, which is 5 root 2. In this one, if you go 3 square, 4 square, 1 square, root 26. This one 1 square, 1 square, 4 square, root 18. Okay, okay. This is also 3 is to 2. So if you see that D point will be dividing it in the ratio of 5 is to 3. So the point D will come out to be 5 into 4, 3 into 1 upon 8. 5 into 3 minus 1 into 5 into 3 minus 1 into 3 upon 8. 5 into 2, 3 into 3 upon 8. So this is what? 23 by 8. Okay, this is coming a bit rough value. 12 by 8. 19 by 8. So the distance AD will come out to be root under 23 by 8 minus 5. 40. 17 whole square. 8 will come out, okay? 12 minus 4, 8. 8 whole square. 8 square. 29 square, 29 square. So this is coming a bit rough value, okay? Find the value of this one. That's all. AD. So I did not want to leave circumcenter, but in circumcenter you will have to solve it. Okay. I'm just simply saying that in circumcenter, if there is a triangle and there is a circle passing through every center, so what will happen? The center of the circle will be equal O, A, B, C. So OA is equal to OB equal to OC. Then O is circumcenter. We don't have any specific formula for this, okay? Orthocenter. In orthocenter, if you are drawing perpendicular, this is perpendicular, okay? And this is perpendicular. And this is perpendicular. Then this intersection is called ortho. This is this point P. P is orthocenter. That's all. Okay. Show that 3, 2, 7, 2, 1, 2 is circumcenter of the triangle whose vertices are this. Okay. And find the orthocenter. So what will happen? We'll have like this we are drawing. We know the corner points. So we know that this is O. O is 3 by 2, 7 by 2, 1 by 2. And ABC we know. So we'll calculate OA. It will come out to be 1 by 4, 1 by 4, 9 by 4. Root 11 by 4, 2. We'll calculate OB, which is 9 by 4, 1 by 4, 1 by 4, which is root 11 by 2. OC, root under 9 by 4, 1 by 4, 1 by 4, root 11 by 2. So that means O is circumcenter proved. Now, orthocenter. This is the time for orthocenter. What will happen? Orthocenter will be a bit magical. A bit magical in the sense, we know that in any triangle, circumcenter, median, circumcenter, median, that is centroid, and orthocenter are in ratio. I think orthocenter, median, and circumcenter, they are in the ratio 2:1. So let's calculate centroid. It is x1, x2, x3, 5 by 3. It is 7, 3, 10. 10 by 3. And this is 3 by 3. Okay. Now we got, this is circumcenter. Okay. We'll keep it C. Circumcenter. So circumcenter and centroid. So orthocenter, if we put orthocenter as x comma y comma z. Oh, okay. So 2 time of circumcenter, like 10 by 3 plus x by 3 is equal to 3 by 2. Similarly, 20 by 3 plus y by 3 is equal to 7 by 2. Similarly, 2 plus z by 3 equal to 1 by 2. So from here, if we find x, oh, 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 9 by 2. So from here, if we find x, 9 by 2 minus 10 by 3. 9 by 2 upon 10 by 3. 27 by 6 upon 20. 20 by 6. 7 by 6. From here, if we find 21 by 2, 63 by 6 minus 40 by 6. 63 by 6. 23 by 6. Z. 3 by 2 minus 2 minus 1 by 2. So we got these points. Okay, these are orthocenter. So are you all willing to study more? Everyone, are you willing to study more? Okay, so it will go uh, so we are done up to 4 lecture. Okay, we'll continue with this lecture next week. For now, bye bye, tata to everyone, and kindly go through these all recorded lectures. Okay, okay.